Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll look at approximating rates of change. So once again, I have here the graph of y equals x squared. We saw in a previous video that the rate of change or the gradient of this function is different at different points along this curve. So let's say I want to approximate. I want to find the rate of change in this region around this point. X is -1, and of course the y value would be 1. So what we looked at was drawing secants. We could draw another point over here, and we could draw a secant like that, and we could calculate the gradient of this line. The problem we identified is, though, that this secant isn't going in the same direction as the curve. It isn't a good approximation to the curve. So what we want to do to try and get a good approximation of the curve in this region, we want the points to be closer together. So these are a bit far apart. So the distance between these 2 points, whatever that point is, we call that the change in x, or sometimes it's written with a lowercase delta. What we're saying when we say that we want the points to be close together, we want this value to be less. We want it to be minimized. We want delta x to be small. So if I want to calculate the gradient of this function in this region here, I want the second point not to be over here, but probably to be around there. So if I put it here, then I draw a secant. This secant here is much more representative of the curve. So it's not perfect, but it does such a better job than the blue line. So if I want to know the rate of change of this function around x equals -1, I can choose my delta x, the change in x value. So let's say, for example, delta x is a small number like 0.1. So the first x value was -1. So delta x is 0.1. That means the next point will be -1 plus 0.1. The next x value will be -0.9. So of course, when x equals -1, y equals 1. When x equals -0.9, y will be -0.9 squared, which is 0.81. So if I want to approximate the rate of change, I now have 2 points. These 2 points are very close together. So the way I calculate the rate of change, which is the gradient of a line that goes through 2 points, I just use the 2-point formula. So we saw that in a previous video too. So the gradient is y2 minus y1 over x2 minus x1. And so the answer I get there is -1.9. So what exactly is this saying? It is saying that in this region, around the point where x is -1, the gradient is -1.9. Around this area, each time we increase x by 1 unit, y is decreasing by about 1.9 units. The gradient of this black secant is -1.9. We've approximated the gradient in this region. It's not a good approximation of the gradient in this region, but as I said, the gradient's different at different points along this curve. So we need to calculate the gradient slightly differently over here than over here. Once again, the black secant, much better representation of how the red graph is changing in this region. So we wanted the points to be closer together. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.